Good morning. Our next topic is biodiesel. We have seen fossil fuels, right? So, fossil fuels are coal, petrol, diesel, kerosene. These fossil fuels will one fine day will get extinct. So, we are supposed to depend on alternate sources of fuels. So, what are the alternate sources of fuel? So, it might be solar energy. Other than solar energy, what is other alternate source? So it's supposed to be in the form of oil. It should be suitable for automobiles. So one such fuel is biodiesel. So biodiesel, how it is obtained? It's obtained using the vegetable waste and animal plants. So today we're going to discuss about the synthesis of biodiesel, chemical process, chemical reactions, the advantages, applications, and disadvantages of biodiesel. Biodiesel is obtained from a renewable source of plant origin. It's usually obtained from vegetable oil such as soybean oil, soybean seeds, sunflower seeds, cotton seeds, rice bran, jatropha seeds, castor seeds, etc. So these oils contain triglycerides. These triglyceride esters or fatty acids will be converted into biodiesel by a process called as transesterification in presence of methanol or alcohol or and sodium hydroxide alkali and catalyst. So triglycerides, not only these vegetable oils, whatever is said above, not only corn, sunflower, cotton seeds, rice bran or any seed oil, it might be also animal fat. So these plant origin oils, animal fat which contains triglyceride will be converted into biodiesel by a process called as transesterification in presence of an alcohol, an alkali and a catalyst. So when we heat this to 60 degrees Celsius, alcohol, that is biodiesel and a glycerol will be formed. So whatever biodiesel is obtained here in this process can be used as an alternate fuel for fossil fuels in almost all automobiles where diesel is used. Now let us see the process of manufacture or synthesis of the biodiesel. So the triglycerides, the plant origin oil or animal fat contains triglycerides. So triglycerides is represented by CH2COOR1, CHCOOR2, CH2COOR3. So where R1, R2, R3 are long chain fatty acids. So any triglyceride for that matter will have this structure. So R1, R2, R3 will vary depending upon the oil and fat which we are taking. So this will be heated in presence of methanol and then alkali, in presence of alcohol and an alkali. So usually we are going to use sodium hydroxide, okay, and if we are using alcohol, that is methanol, we'll see what product we are going to obtain. So we are going to take the triglyceride, we are going to add methanol, presence of sodium hydroxide and catalyst we are going to heat. When we heat to 60 degrees Celsius, we are going to obtain fatty acid methyl ester, this FAME, and glycerol. So instead of using methanol, if we are using ethanol, we get fatty acid ethyl ester. Instead of using methanol, if we are using ethanol, we get fatty acid ethyl ester. If we are using methanol, we get fatty acid methyl ester. Whether it is methyl ester or ethyl ester, both are called as biodiesel. This biodiesel and glycerol are separated from each other by a process called as chromatography. By chromatographic technique, biodiesel is separated from glycerol. Glycerol is used in various petrochemical industries. It is used for various medical applications also. So keep glycerol aside. So let us see what are the advantages, disadvantages and applications of thus obtained biodiesel. So the triglyceride treated with methanol and an alkali, we get biodiesel and glycerol. Thus obtained biodiesel is separated from glycerol by a technique called as chromatography. That is chromatographic technique. So I take crude oil, okay, crude algal oil, undergoes esterification to give ester oil. This ester oil undergoes trans-esterification to give biodiesel and glycerin. Due to density, the glycerol will be settled down and biodiesel will be top. This is as per weight percentage. For how much if you are taking the value, you are going to obtain so much percentage of the biodiesel. So advantages. The main advantage here is the pure biodiesel is called as B100. This pure biodiesel can be used in the diesel engine without much changes in the engine design. So it is called as B100. It can use directly as it is. So this biodiesel has a shorter ignition delay. So the working is completely different from the working of diesel engine is completely different from gasoline engine or petrol engine. So here what happens? So any diesel vehicle will have a separate space for air and separate space for diesel. First the air will enter into the engine, so it will be compressed. So when air is compressed, the temperature will go very high. At that particular temperature, the diesel droplets will be allowed to go. As soon as diesel droplets goes inside, it should undergo combustion and energy will be liberated. So as soon as the diesel droplets falls, if there is a delay in ignition, it is called as ignition delay. So due to ignition delay, knocking occurs here. So ignition delay is the main reason for knocking in biodiesel. Remember that. Okay. So this biodiesel has a shorter ignition delay, therefore less chances of knocking. So biodiesel has shorter ignition delay compared to normal diesel. And this biodiesel has no sulfur content, rather we can tell less or no sulfur content. Okay, and the particulate matter whichever is produced is also less. So since there is no sulfur, there is chances of getting acid rain is also less. Then what are the disadvantages? So biodiesel, it is significantly expensive compared to diesel. So biodiesel releases oxides of nitrogen. So these oxides of nitrogen may cause smog, that is air pollutant, and these oxides of nitrogen will also damage the ozone, which will lead in ozone hole. So because of that, so if you are using only the rice bean oil, food oil, waste oils, then it's okay. So if you are taking only using this for preparation of biodiesel, one fine day what will happen? There will be a shortage of food. So these are the disadvantages of biodiesel synthesis. Let us see the applications of biodiesel. So biodiesel can be directly used in the engine where normal diesel is used without much modification in the engine design. Okay, so the B100 is the pure biodiesel. Okay, so we have in Bangalore, I don't know how many might have seen. So we have a green color buses where they would have put a tick mark and would have written eco-friendly. So those eco-friendly buses use biodiesel as the fuel. Biodiesel, it varies from B20, B30, B40 to B50. What is B20? 20% of biodiesel, 80% of normal diesel. B30, 30% of biodiesel, 70% of normal diesel. B40, 40% of biodiesel, 60% of normal diesel. B50, 50% of biodiesel, 50% of normal diesel. So usually B20 is used in almost all eco-friendly vehicles. So if you're using B20 itself, it brings down the emission to greater extent. So biodiesel can also be used as a supplement for home heating oils. So these are the applications of biodiesel. Thank you.